Imagine a realm so vast, so boundless that it defies human comprehension, a place where reality is more bizarre than the wildest fiction ever dreamed. In this incredible expanse, stars are born in fiery chaos, mysterious signals whisper across the void, and planets roam untethered, defying the very laws of gravity. The galaxy is not just a collection of stars and cosmic dust. It's a living, breathing tapestry of wonders, each more astonishing than the last. What if I told you there are stars older than the galaxy itself? Or that entire galaxies can consume one another in cosmic collisions? These are not just stories, they are truths waiting to be uncovered. Today, we're diving into 30 of the most bizarre galactic facts that will challenge everything you thought you knew about our universe. So, buckle up as we embark on a journey into the unknown, where the mysteries of space will leave you awestruck, questioning, and utterly amazed. Now turning to the astonishing phenomenon of galactic cannibalism, imagine galaxies as cosmic giants locked in a slow, graceful dance that often ends in a dramatic act of consumption. Galaxies do not merely coexist in the cosmos, they interact in ways that are as awe-inspiring as they are violent. Take the Andromeda galaxy, for instance, our nearest galactic neighbor. Hurtling toward the Milky Way at an incredible speed of over 100,000 miles per hour, Andromeda is set on a collision course with our own galaxy, a fate that will play out approximately 4 billion years from now. When these titanic structures collide, it is not the explosive chaos you might imagine. Instead, the gravitational forces of these cosmic entities pull and warp their shapes, flinging stars into new orbits while others are ejected into the vastness of intergalactic space. Remarkably, the vast distances between individual stars mean that direct stellar collisions are extremely rare, but the gravitational turbulence often triggers new waves of star formation, breathing life into parts of the galaxies. The result, after billions of years, is a single, unified galaxy, a process that has happened countless times throughout the universe's history. These collisions are not acts of destruction, but rather cosmic rebirths, reshaping the very fabric of the galaxies involved. This extraordinary phenomenon serves as a humbling reminder of the dynamic and ever-evolving nature of the universe we inhabit. Moving forward, let's unravel the secrets of a mysterious substance that holds galaxies together yet remains completely invisible to the human eye. Now turning to the enigmatic concept of dark matter, let's delve into this invisible substance that challenges our understanding of the cosmos. Making up about 27% of the universe, dark matter is neither visible nor directly detectable, yet its presence is crucial to the formation and stability of galaxies. Imagine galaxies as colossal islands of stars, held together not just by gravity from visible matter but also by an unseen force. This is where dark matter comes into play. Without it, the gravitational pull of ordinary matter would be insufficient to hold galaxies intact, and they would scatter into the void of space. Scientists have inferred the existence of dark matter through its gravitational effects, such as the way it bends light from distant stars in a phenomenon known as gravitational lensing, or the way galaxies rotate at speeds that cannot be explained by visible mass alone. Despite this indirect evidence, no one has been able to observe or interact with dark matter directly. Various theories propose that it is made of exotic particles that do not emit, absorb, or reflect light, rendering them invisible to traditional detection methods. The pursuit to uncover the true nature of dark matter is one of modern science's greatest mysteries, with experiments around the world attempting to capture even the faintest hint of its existence. This elusive substance is not just a scientific curiosity, it is fundamental to our understanding of the universe's structure and evolution. As we continue our journey through the cosmos, let's shift our focus to a peculiar phenomenon that defies traditional planetary systems, planets set adrift in the void of space with no stars to call home. Moving forward, let's explore the fascinating mystery of rogue planets, celestial wanderers that defy the conventional rules of planetary systems. Unlike the planets in our solar system that orbit a star, rogue planets drift aimlessly through the vast expanse of space, untethered to any stellar companion. These lonely worlds are believed to form in ways quite similar to regular planets, beginning as swirling clouds of gas and dust that coalesce under gravity. However, violent interactions within their original star systems, such as gravitational pushes from larger planets or close encounters with neighboring stars, can eject these planets into interstellar space. Once expelled, they roam the galaxy, carrying no sunlight to guide their path and no star to call home. Detecting rogue planets is an extraordinary challenge since they emit no light of their own and lack the reflective glow provided by a nearby star. Astronomers rely on techniques like gravitational microlensing, where the rogue planet's gravity bends and magnifies the light of a distant background star as it passes in front of it. This fleeting event provides a rare glimpse into their existence. Some rogue planets are thought to be as large as gas giants, while others might be rocky and Earth-sized. What makes them even more intriguing is the possibility of subsurface oceans or internal heat generated by their own cores, raising speculative questions about whether they could harbor some form of life. These wandering worlds highlight the extraordinary diversity of planetary systems in our galaxy, challenging the very definition of what it means to be a planet. As we marvel at their solitary journeys across the cosmos, let us now turn our attention to the awe-inspiring scale of our own galactic home, the Milky Way, and uncover its staggering weight in sun-like units. Now turning to the staggering scale of our own galaxy, the Milky Way, did you know that its estimated weight is equivalent to an astonishing 1.5 trillion suns? This mind-boggling figure includes not just the visible stars, planets, and gas, but also the elusive dark matter that makes up a significant portion of our galaxy's mass. To put this into perspective, dark matter alone constitutes the vast majority of the Milky Way's total weight, while the stars and gas we can see are just a fraction of the whole picture. But how do scientists even measure something as immense and intangible as the weight of an entire galaxy? They use advanced computer simulations and study the motion of stars and other celestial objects within the Milky Way's gravitational field. By analyzing how these objects move, whether they are orbiting closer to the galactic center or further out in the halo, scientists can estimate the amount of mass required to produce the observed gravitational effects. These measurements reveal not just the visible components, but also the unseen dark matter that holds the galaxy together. What makes this figure even more impressive is that our galaxy is just one among billions in the universe, many of which are even larger. Yet, this colossal weight serves as a reminder of just how complex and massive our cosmic neighborhood truly is. With this incredible revelation in mind, let us move on to another cosmic concept that stretches the boundaries of our understanding, the galactic year, and explore how our sun's journey around the Milky Way ties us to the rhythms of deep time. Moving forward, let's delve into the fascinating concept of a galactic year, the immense timescale that governs the motion of our solar system within the Milky Way. A galactic year refers to the time it takes for the Sun, along with its orbiting planets, including Earth, to complete one full orbit around the center of our galaxy. Unlike the familiar Earth year, which measures the time it takes for our planet to orbit the Sun, a galactic year operates on a scale so vast that it defies everyday comprehension. To complete this epic journey, the Sun takes an estimated 225 to 250 million Earth years. Imagine that just one galactic year covers a span of time longer than the entire age of the dinosaurs on Earth. In fact, the last time our solar system occupied this exact position in the Milky Way's orbit, dinosaurs like the mighty Tyrannosaurus roamed the planet. This incredible journey is governed by the gravitational forces of the galaxy's central supermassive black hole and the Milky Way's vast distribution of stars, gas, and dark matter, which collectively determine our orbital path. The sheer scale of a galactic year provides us with a humbling perspective on the enormity of time and space, connecting us to cosmic rhythms that span hundreds of millions of years. With this awe-inspiring sense of time in mind, let us now turn our attention to the mysterious entities that anchor galaxies themselves, the supermassive black holes at their centers. Now turning to the enigmatic forces at the heart of most galaxies, we encounter the supermassive black holes that act as cosmic anchors, holding entire galaxies together with their extraordinary gravitational pull. At the center of our own Milky Way lies an immense supermassive black hole known as Sagittarius, a star. This colossal entity has a mass equivalent to over 4 million suns packed into a space no larger than the orbit of Mercury around the Sun. Despite their name, black holes do not actively pull in everything around them like cosmic vacuums. Instead, their immense gravity governs the motion of nearby stars, gas clouds, and even entire planetary systems, ensuring the stability of the galaxy's structure. In the case of Sagittarius, a star, its gravitational influence is so profound that it shapes the orbits of millions of stars in the galactic core, creating a central region bustling with high-speed stellar motion. Astronomers have observed stars near this black hole whipping around it at incredible speeds, with some traveling a mind-boggling 16,000 kilometers per second. Yet, as mysterious and powerful as they are, supermassive black holes remain one of the greatest puzzles of modern astrophysics. Scientists continue to study how these colossal objects form, whether through the merging of smaller black holes, the collapse of massive early stars, or perhaps other unknown processes. They also investigate the role supermassive black holes play in a galaxy's evolution, as their energetic activity can sometimes expel massive amounts of gas, regulating star formation across the galaxy. With their sheer magnitude and far-reaching influence, supermassive black holes like Sagittarius, a star, remind us of the immense and often hidden forces that govern our universe. Staying in the realm of cosmic phenomena, let us now explore the fascinating discovery of stars that may be older than our own galaxy itself. Moving forward, let us uncover an extraordinary discovery that challenges our understanding of time itself: stars that appear to be older than the Milky Way galaxy. Among these ancient celestial bodies is a remarkable star known as HD 140,283, often referred to as the Methuselah Star. Situated roughly 200 light-years away from Earth, this star has captivated astronomers due to its astonishingly old age. Initial estimates placed its age at around 14.5 billion years, which intriguingly is older than the calculated age of the universe itself, estimated to be around 13.8 billion years. Although later studies have refined this estimate, suggesting it is slightly younger but still unthinkably ancient, its discovery raises profound questions about the early history of the cosmos. The Methuselah Star is a population 2 star, meaning it formed when the universe was still in its infancy and primarily consisted of hydrogen and helium with very few heavier elements. This scarcity of heavy elements in its composition provides a direct link to the earliest stages of cosmic evolution, moments after the Big Bang, when the first stars began to illuminate the darkness of space. The existence of such stars offers crucial insights into galaxy formation, as it suggests that the building blocks of galaxies like the Milky Way may have begun assembling long before the galaxy itself fully took shape. By studying stars like HD 140,283, scientists can piece together the timeline of the universe, unlocking secrets about the birth of galaxies, the formation of the first elements, and the transitions that set the stage for the universe we observe today. These ancient stars are like time capsules, offering us a rare glimpse into a period so far removed from our own that it stretches the limits of our imagination. Now, as we journey further into the cosmic wonders that defy our understanding, let us explore hypervelocity stars blazing through the galaxy at unimaginable speeds. Now turning to the astonishing phenomenon of hypervelocity stars, these celestial objects race through the galaxy at breathtaking speeds, reaching millions of miles per hour. Unlike most stars, which are gravitationally tethered within the orderly dance of the galaxy, hypervelocity stars break free from these constraints, launching on trajectories that can carry them far beyond their home galaxies into the vastness of intergalactic space. But how do these stellar speed demons come into existence? Scientists believe one of the primary mechanisms involves interactions with supermassive black holes. Imagine a binary star system, a pair of stars locked in orbit around each other, venturing too close to a black hole. The immense gravitational force of the black hole can tear the pair apart, consuming one star while slingshotting the other away at mind-boggling speeds. Another potential origin lies in the violent aftermath of a supernova explosion, where the intense force of the blast can propel a companion star outward at extraordinary velocities. These scenarios underscore the immense and often chaotic gravitational forces at play in the universe. What makes hypervelocity stars particularly fascinating is not just their speed, but also what they can reveal about the galaxy. By tracking their motion and paths, astronomers can map the hidden gravitational influences within the Milky Way, uncovering clues about the distribution of dark matter that cannot be observed directly. Moreover, these stars may carry with them vital information about the regions from which they originated, acting as cosmic messengers from the galactic core or other dense stellar environments. Their existence challenges our understanding of galactic dynamics and offers a unique opportunity to explore the interplay of immense forces that govern the universe. As we marvel at these speeding anomalies, let us shift our focus to yet another enigmatic feature of the cosmos, the intergalactic medium, a vast expanse that connects and separates galaxies alike. Now turning to the intergalactic medium, this vast and diffuse expanse of gas stretches across the cosmic voids between galaxies, acting as both a bridge and a barrier in the universe's grand structure. Though it may seem empty to the casual observer, the intergalactic medium is far from lifeless. It is composed of ionized hydrogen and helium, along with traces of heavier elements. This scattered material may appear insignificant, but its importance cannot be overstated. Scientists believe it holds vital clues about the composition and history of the universe, offering a glimpse into how galaxies form, evolve, and interact over billions of years. Studying the intergalactic medium is no simple task, however. Its faint and nearly invisible nature makes it one of the most elusive components of the cosmos. Researchers rely on advanced tools like space-based telescopes to detect its presence, often by observing how it absorbs or scatters light from distant quasars, those brilliantly luminous objects powered by supermassive black holes at the centers of galaxies. These observations have uncovered the role of the intergalactic medium as a cosmic archive, preserving information about events like the synthesis of elements in early stars or the epic collisions between galaxies. Another fascinating aspect of the intergalactic medium is its role in the cosmic web, the large-scale structure of the universe. This web is composed of intricate filaments of dark matter, gas, and galaxies that stretch across unimaginable distances. The intergalactic medium acts as the connective tissue of this web, outlining the vast framework that holds the universe together. By mapping these filaments, scientists can probe the distribution of dark matter, refine models of cosmic evolution, and even understand the mysterious force of dark energy driving the expansion of the universe. The study of the intergalactic medium is not just about understanding what lies between galaxies. It is about uncovering the hidden forces that shape and perpetuate the cosmos itself. As we delve deeper into the mysteries of this ethereal expanse, our journey continues to yet another astonishing phenomenon: quasars, the powerhouse beacons of ancient galaxies that illuminate the darkest corners of the early universe. Now turning to quasars, these extraordinary cosmic phenomena are among the most luminous and energetic objects in the universe. Found at the centers of certain galaxies, quasars are powered by supermassive black holes that consume vast amounts of surrounding matter. As this matter spirals into the black hole's accretion disk, it generates an immense amount of energy, producing light so intense that a single quasar can outshine its entire host galaxy. This dazzling radiance travels across billions of light years, acting as a beacon that allows scientists to peer deep into the early universe. Quasars are not only awe-inspiring for their brilliance, but also invaluable tools for understanding the cosmos. Because the light from quasars has traveled such incredible distances, it carries with it a record of the universe's distant past. By analyzing this light, astronomers can unravel clues about the conditions and processes that existed when the universe was young. Quasar observations have shed light on the formation and growth of early galaxies, the distribution of matter in the universe, and even the properties of the mysterious intergalactic medium. One of the most intriguing aspects of quasars is their ability to illuminate the large-scale structure of the universe. As their light passes through the cosmic web, it is absorbed and scattered by the gas and dark matter filaments that connect galaxies. By studying these interactions, scientists can map the invisible scaffolding of the universe and understand how it evolves over time. Quasars also provide critical insights into the role of supermassive black holes in galactic evolution, revealing how these cosmic giants shaped their surroundings with powerful jets and winds. Their discovery remains one of the most significant milestones in modern astronomy, and their study continues to unlock the secrets of the early universe. As we uncover the mysteries of these brilliant cosmic lighthouses, our journey through the galaxy brings us to another powerful force shaping the cosmos' galactic winds, the immense outflows of gas that sculpt and transform entire galaxies. Moving forward, let's explore the monumental phenomenon of galactic winds, the immense outflows of gas that play a crucial role in shaping the evolution of galaxies. These winds, often driven by the intense activity of supermassive black holes or the rapid formation of stars, act as a cosmic force that influences the very fabric of a galaxy. When a supermassive black hole at the center of a galaxy consumes matter, it unleashes tremendous energy that propels gas outward in powerful streams. Similarly, when clusters of stars are born in massive bursts, the combined energy from stellar winds and supernova creates immense gusts that push gas away from the star-forming regions. These galactic winds are not merely fleeting disturbances but transformative forces that regulate the life cycle of galaxies. By expelling gas, they can halt star formation in certain areas, effectively determining the growth and structure of the galaxy over time. On the other hand, they can also transport gas to other regions, triggering the birth of new stars and seeding the intergalactic medium with essential elements like carbon and oxygen. This interplay of destruction and creation ensures the dynamic nature of the universe, where galaxies continuously evolve and adapt. Galactic winds also serve as a key mechanism for distributing the chemical building blocks of life across the cosmos, enriching the surrounding space and laying the groundwork for future star systems. As scientists study these vast outflows, they gain deeper insights into how galaxies interact with their environments and how the universe maintains its delicate balance. From sculpting galaxy shapes to influencing how and where stars are born, galactic winds are truly one of the most fascinating forces at play in the cosmos. With this understanding, our journey takes us to another remarkable celestial phenomenon, pulsars, the rapidly spinning neutron stars that serve as nature's most precise lighthouses. Now turning to pulsars, these remarkable celestial objects are neutron stars that spin at incredible speeds, emitting beams of radiation from their magnetic poles. Imagine a cosmic lighthouse with its beams sweeping regularly across the galaxy. This regularity is what makes pulsars so extraordinary. Formed from the collapsed cores of massive stars after supernova explosions, these dense remnants can spin hundreds of times per second, offering a level of precision that rivals even the most advanced atomic clocks on Earth. Astronomers use pulsars as natural timekeepers to study a wide range of cosmic phenomena. By tracking their pulses with great accuracy, scientists can measure time and space with unprecedented precision, using them to test fundamental theories like Einstein's general theory of relativity. Pulsars also help in detecting gravitational waves, ripples in the fabric of space-time caused by massive cosmic events, such as black hole collisions. A specific type of pulsar, known as millisecond pulsars, rotates so fast that they complete hundreds of rotations in just 1 second, providing exceptionally stable signals that serve as tools for mapping these mysterious waves. Beyond their use in scientific research, pulsars offer insights into the life cycle of stars and the extreme conditions of matter under intense gravitational forces. The dense interior of a pulsar is composed of neutrons packed so tightly that just a sugar cube-sized portion would weigh billions of tons on Earth. Their study not only enhances our understanding of the universe, but also challenges the limits of physics as we currently know it. These spinning beacons connect us to the dynamic processes of stellar evolution and carry clues about the events that shape the cosmos. With pulsars shining their light on so many cosmic mysteries, we now move forward to uncover even more enigmas of the universe, like the vast and almost invisible intergalactic medium that lies between galaxies. Moving forward, let us explore one of the most breathtaking discoveries in the structure of the universe, the Great Galactic Wall. Imagine a cosmic tapestry so vast that it stretches across billions of light years, composed of countless galaxies woven together by gravity. The Great Galactic Wall is one of these superstructures, an expansive region containing clusters of galaxies connected like threads in a colossal web. These walls are not solid structures, but rather immense networks of galaxies surrounded by vast voids, forming the large-scale architecture of the cosmos. Scientists detected these formations by mapping the positions of galaxies using precise observations of their light. By analyzing redshifts, the stretching of light caused by the universe's expansion, they can determine the distances of galaxies from Earth and reveal these remarkable patterns. The discovery of the Great Galactic Wall and similar structures, like the Sloan Great Wall and the Hercules Corona Borealis Great Wall, challenges our understanding of how the universe evolved. These superstructures suggest that not only are galaxies grouped in clusters, but these clusters come together to form unimaginably large arrangements, shaped by the forces of dark matter and gravity over billions of years. Such discoveries deepen our perspective on just how vast and interconnected the universe truly is, with galaxies moving over cosmic timescales in a celestial dance influenced by these large-scale patterns. By studying these colossal walls, researchers gain insight into the distribution of matter and energy in the universe, as well as the mysterious role of dark matter in knitting cosmic structures. These findings push the limits of what we know about the formation of galaxies and the intricate framework that holds the universe together. Now, with the colossal scale of the Great Galactic Wall in mind, let us journey even further to investigate the mysterious and energetic phenomena of quasars, which outshine entire galaxies with their power. Now turning to the enigmatic phenomena of cosmic signals from deep space, let us delve into the mystery of fast radio bursts. These elusive and powerful bursts of radio waves last only milliseconds, yet they release as much energy as the sun does in an entire day. First discovered in the early 2007, fast radio bursts, or FRB, have puzzled scientists ever since. Their origins remain a subject of intense debate, with theories ranging from natural astrophysical phenomena to speculative hints of extraterrestrial technology. One leading explanation involves neutron stars, which are dense remnants of massive stars that have exploded as supernova. Specifically, a type of neutron star called a magnetar, known for its incredibly strong magnetic fields, is thought to produce FRBs through sudden bursts of energy. Another possibility points to the merging of compact objects like neutron stars or black holes, events so cataclysmic that they ripple through space with detectable signals. Yet, amidst these scientific explanations, some researchers have dared to consider the possibility of advanced alien civilizations using these signals as a form of interstellar communication. While this idea remains highly speculative, it captures the imagination of scientists and the public alike. Detecting and studying FRBs poses unique challenges, as their fleeting nature requires precise and rapid observations. Advanced radio telescopes like the Canadian Hydrogen Intensity Mapping Experiment and the Parkes Observatory in Australia have played pivotal roles in identifying dozens of these signals, helping to unveil patterns and even repeating FRBs from the same source. These repeating signals in particular intrigue researchers as they suggest a persistent and unknown cosmic mechanism. The study of fast radio bursts not only deepens our understanding of extreme astrophysical processes, but also opens the door to profound questions about the universe and our place within it. As technology advances and more FRBs are detected, scientists hope to piece together the puzzle of these fleeting, high-energy phenomena. Now, as we ponder the captivating mystery of these bursts from the deep, let us turn our gaze to one of the largest and most luminous objects in the universe, the incredible quasars. Now turning to the awe-inspiring realm of gigantic stars, let us explore Scuti, one of the largest stars ever discovered. This colossal star resides in the constellation Scutum, roughly 9,500 light-years away from Earth. To grasp its sheer magnitude, consider this. Scuti's radius is estimated to be over 1,700 times that of our Sun. If you were to place this star at the center of our solar system, its outer layers would extend past the orbit of Jupiter, engulfing our inner planets and the asteroid belt with ease. Despite its immense size, Scuti is classified as a red supergiant, a type of star nearing the final stages of its life. What makes it particularly fascinating is how it challenges our perception of stellar dimensions. Compared to our comparably tiny Sun, Scuti almost defies the limits of what we imagine a star can be. However, it is important to note that Scuti is not the most massive star in terms of weight. While its size is utterly enormous, its overall mass, estimated at around 30 to 40 times that of the Sun, is much lower than stars like R136A1, which holds the record for stellar mass. Scuti's immense size is due to its low density and extended outer layers, making it more voluminous than dense. Stars like this not only push the boundaries of astrophysical understanding, but also offer a glimpse into the life cycles of the universe's behemoths. With every observation, scientists refine their models of how stars evolve, expand, and eventually collapse. As immense as Scuti is, it serves as a humbling reminder of the vast diversity and scale within our universe. Now, having marveled at the extraordinary dimensions of this gigantic star, let us journey to the loneliest corners of the cosmos, where entire galaxies drift in solitude. Now turning to the loneliest corners of the cosmos, let us explore galaxies like NGC 6503, a galaxy renowned for its solitude. Located roughly 18 million light-years away in a region of space called the local void, NGC 6503 drifts in near isolation, far removed from the busy clusters of galaxies that populate most of the universe. But why do some galaxies like this exist in such desolation? The answer lies in the large-scale structure of the universe. Imagine vast cosmic webs composed of filaments where galaxies cluster together, interspersed with immense voids that are almost entirely empty. NGC 6503 resides right at the edge of one of these voids, making it an enigmatic outlier. Its lonely existence provides scientists with exceptional opportunities to study a galaxy unperturbed by the gravitational influences of nearby neighbors. This means its structure and evolution unfold in relative isolation, offering a unique perspective on how galaxies can develop in such environments. The idea of a galaxy existing in such solitude, light years away from any significant interaction, challenges our understanding of how the universe's vast structures were formed after the Big Bang. It raises profound questions about how the cosmic web's intricate patterns, shaped by dark matter and other forces, determine where galaxies form and where voids persist. This galactic loneliness portrays an isolated beauty and serves as a reminder of the incredible diversity in our universe's architecture. Moving forward, let us consider some of the most mysterious phenomena in the galaxy zombie stars and their remarkable ability to reignite after apparent death. Moving forward, let us delve into the enigmatic world of zombie stars, celestial phenomena that show us how even in apparent death, stars can find a way to revive. When a star exhausts its nuclear fuel and collapses into a dense remnant called a white dwarf, it might seem like the end of its life. However, if this white dwarf exists in a binary system where it orbits closely with another star, its story might not be over. Over time, the white dwarf can pull gas and material from its stellar companion, accumulating enough mass to reignite nuclear fusion on its surface. This dramatic process can reach a critical point, triggering a thermonuclear explosion known as a Type Ia supernova. These explosions are incredibly bright, often outshining entire galaxies for a brief period, and they serve as critical tools for scientists studying the universe. Because Type Ia supernova produce a consistent amount of light, astronomers use them as cosmic measuring tapes to determine distances across vast stretches of space. The ability of a dead star to transform into such a spectacular event reminds us of the universe's capacity for renewal and change, even in the most unexpected ways. With this understanding of zombie stars in mind, let us explore an equally mystifying galactic component, the mysterious force accelerating the universe's expansion, known as dark energy. Now turning to the mystery of dark energy, we find ourselves face to face with one of the most baffling phenomena in modern astrophysics. Dark energy is a mysterious and invisible force that scientists believe makes up nearly 70% of the universe. Its existence was first suggested in the late 1990s, when astronomers observing distant supernovae discovered that the universe's expansion was not slowing down as previously thought, but was instead speeding up. This acceleration defies the expectations of gravity and suggests the presence of an unknown force acting against it. While we cannot see or directly detect dark energy, its effects are observed on cosmic scales. One of the leading theories is that dark energy could be connected to the vacuum energy of space itself, a property of the quantum realm that suggests even seemingly empty space is filled with energy. Another hypothesis involves a dynamic field, sometimes called quintessence, that changes over time and space. Despite decades of study, the true nature of dark energy remains a profound mystery, challenging our fundamental understanding of physics. Even more fascinating, the fate of the cosmos may rest in its hands. If dark energy continues to dominate, the universe could expand forever, growing colder and emptier as galaxies drift further apart. Alternatively, if its properties shift over time, it could lead to scenarios such as a big freeze, a big rip, or even a cosmic rebound. Whatever the ultimate truth, dark energy remains a powerful reminder of how much about the universe is still unknown. With this in mind, let us explore areas of the galaxy where life itself begins: galactic gardens, the star-forming regions of the cosmos. With the next phase of the journey in sight, let us uncover the wonders of galactic gardens, the star-forming regions where the cosmos gives rise to new life. These stellar nurseries, as they are often called, are vast clouds of gas and dust, the essential ingredients for star creation. One of the most well-known examples is the Orion Nebula, a stunning region about 1,350 light-years away from Earth. This immense cloud of interstellar material not only dazzles with its vibrant hues, but also serves as a cradle for hundreds of newborn stars. Within these nurseries, gravity works its magic, pulling gas and dust together until the pressure and heat ignite nuclear fusion, the process that powers stars. Over time, neighboring stars and planets can form from the leftover material, creating entire solar systems. These regions are not just visually stunning, but also vital to the ongoing cycle of the universe, replenishing the galaxy with new stars as older ones burn out or explode as supernova. Beyond the Orion Nebula, other remarkable star-forming regions include the Eagle Nebula, famous for the iconic pillars of creation, and the Carina Nebula, home to some of the brightest and most massive stars ever discovered. By studying these regions, astronomers gain valuable insights into how stars and planets, including our own Sun and Earth, came into existence. These cosmic gardens are a testament to the universe's endless creativity, sowing the seeds of future galactic wonders. As we marvel at these breathtaking birthplaces of stars, let us explore another astonishing aspect of the cosmos: stars capable of consuming their own planets. Now turning to stars that devour their own planets, we uncover a dramatic and inevitable phase in the life cycle of certain stars. As stars like our Sun age, they eventually begin to run out of the hydrogen fuel that powers their immense energy. This triggers a transformation into what astronomers call a red giant, an expanded and cooler version of the star that grows to an enormous size. During this stage, the star's outer layers can swell up to hundreds of times its original radius, reaching out to engulf any nearby planets in its orbit. Imagine entire worlds being consumed by the fiery embrace of their parent star, torn apart and vaporized into cosmic dust. Observations of distant star systems have revealed examples of planets at risk of this fate or in the aftermath of such an event. One fascinating case is a planetary system surrounding a red giant star known as HD 100824. Evidence suggests that some of its planets might already have been consumed, leaving behind telltale traces of debris in the star's atmosphere. For our solar system, this process is not just a far-off cosmic idea, but a future reality. Billions of years from now, when our Sun depletes its hydrogen supply, it too will expand into a red giant, potentially engulfing Mercury, Venus, and even Earth. While this may sound ominous, the process is a natural part of stellar evolution and contributes to the recycling of materials within the galaxy, enriching the surrounding space with elements that can eventually form new stars and planets. This dramatic transformation reminds us of the impermanence of cosmic structures and the delicate balance of life in the universe. With the immense power of stars fresh in our minds, let us now explore a phenomenon that takes us into the eerie realm of ghost galaxies. Now turning to the enigmatic world of ghost galaxies, we encounter one of the most mysterious structures in the cosmos. These ultra-diffuse galaxies, often described as faint, shadowy imprints of traditional galaxies, are remarkable not for what they possess, but for what they seem to lack. Containing only a sparse scattering of stars, these galaxies are incredibly dim, almost invisible against the vast backdrop of space. Despite their ghostly appearance, they are believed to be teeming with a hidden substance that holds them together: dark matter. Dark matter, an invisible and still poorly understood form of matter, provides the gravitational glue that prevents these galaxies from falling apart. This unusual composition makes ghost galaxies a fascinating puzzle for astronomers, defying many of the assumptions about how galaxies form and evolve. Observations of these structures show that they can be as large as the Milky Way, yet possess only a fraction of its stars, making them a curious anomaly in the cosmic landscape. One particularly famous ghost galaxy is named Dragonfly 44, located in the Coma cluster, which appears to have an extraordinary amount of dark matter compared to its visible components. Its discovery stunned scientists, as it suggests that dark matter can dominate in ways not yet fully understood. Studying ghost galaxies not only deepens our understanding of dark matter, but also challenges the models of galaxy formation, forcing researchers to rethink the mechanisms that sculpt the universe. What is even more intriguing is that these faint galaxies might hold clues about the distribution of dark matter throughout the cosmos. Every faint glow and hidden shadow in these galaxies tells a story about the forces that shape them, serving as a reminder that even the most unassuming corners of the universe can conceal profound mysteries. With ghost galaxies fading into the backdrop, let us now journey toward an even more thrilling realm where gravitational forces act as interstellar highways, guiding exploration and discovery. Moving forward, we arrive at the fascinating concept of the galactic superhighway, a phenomenon that transforms gravity from an obstacle into an advantage. Gravitational assists, also known as gravity slingshots, are a technique used by spacecraft to gain speed and change direction by passing near massive celestial bodies. Imagine a spacecraft approaching a planet or moon. As it falls into the gravitational pull of this large object, it accelerates and is then flung away at a higher speed, much like a slingshot propelling a stone. This ingenious method allows spacecraft to conserve precious fuel while achieving incredible speeds that would otherwise be unattainable. Scientists have used gravitational assists in some of the most ambitious space missions, such as the Voyager spacecraft, which harnessed the gravitational forces of multiple planets to explore the far reaches of our solar system and beyond. This technique is not only essential for current exploration, but also holds the key to future interstellar travel. By carefully planning trajectories and leveraging the gravitational wells of planets, stars, or even entire galaxies, humanity could one day navigate vast distances that currently seem impossible. The galactic superhighway offers a glimpse into a future where gravitational forces might guide our species toward new frontiers, expanding our reach into the cosmos. With gravity propelling us forward, let us now shift our focus to the most distant reaches of the universe, where ancient galaxies whisper secrets about the origins of everything we see today. With the next phase of the journey in sight, let us turn our attention to the farthest galaxy ever observed, a discovery that takes us back to the dawn of the universe itself. This galaxy, known as GNZ 11, holds the title of one of the most ancient and distant galaxies ever detected. Astronomers estimate that it formed a mere 400 million years after the Big Bang, making it a time capsule from the early days of the cosmos. To put this into perspective, the light we see from GNZ 11 began its journey over 13 billion years ago, traveling across the vast expanse of the universe to reach us today. But how do astronomers achieve such incredible feats of observation? The answer lies in the combination of advanced telescopes and a phenomenon known as redshift. As light from distant galaxies travels through the ever-expanding universe, its wavelength stretches, shifting towards the red end of the spectrum. By measuring this redshift, scientists can determine both the distance and age of these galaxies. The discovery of GNZ 11 was made possible through the Hubble Space Telescope, and it provides a glimpse into a time when the universe was still in its infancy, filled with rapidly forming stars and nascent galaxies. These ancient relics offer invaluable clues about the conditions that shape the cosmos as we know it. Observing them allows scientists to piece together the story of how the first galaxies came into being, shedding light on the origins of stars, planets, and ultimately life itself. And as we marvel at the secrets of GNZ 11, we are reminded that the universe holds even more mysteries waiting to be uncovered. Speaking of cosmic enigmas, let us now shift our focus to the process of galactic recycling, a cosmic cycle that ensures the building blocks of life are endlessly renewed. Now turning to the fascinating process of galactic recycling, we uncover one of the most remarkable cycles in the cosmos. Unlike the wasteful patterns we often observe on Earth, the universe has its own way of reusing and renewing its resources. Galaxies are constantly recycling their materials through incredible cosmic phenomena. One of the most prominent processes involves supernova explosions, cataclysmic events that occur when massive stars reach the end of their life cycle. These violent explosions scatter elements like carbon, oxygen, and iron throughout the galaxy, enriching the surrounding interstellar medium with the ingredients necessary for new stars and planets. But the recycling does not stop there. Stellar winds, the powerful streams of particles ejected by stars during their lifetimes, also play a critical role in dispersing these essential elements into the galaxy's vast expanse. These winds help distribute the raw materials needed to form everything from star-forming regions to planetary systems. Through this ongoing process, galaxies create and recycle the very building blocks of life. The carbon in your body, the oxygen you breathe, and even the iron in your blood were likely forged in the heart of a star billions of years ago, and then redistributed across the cosmos through these recycling mechanisms. This constant renewal ensures that the universe remains dynamic and ever-evolving, providing endless opportunities for creation and transformation. Galactic recycling illustrates how interconnected everything in the universe truly is, linking the birth of stars to the existence of life itself. It is a cosmic reminder that nothing in the universe is wasted, but rather everything contributes to a greater cycle of renewal. And with this awe-inspiring process fresh in our minds, let us now venture into the mysterious regions of the cosmos known as the voids, where the absence of galaxies tells an entirely different story. Now turning to the enigmatic phenomenon of the cosmic voids, we find ourselves exploring regions of the universe that challenge our understanding of its structure. One of the most famous voids, the Borealis void, is often referred to as a cosmic desert due to its astonishing lack of galaxies. Spanning an incredible distance of approximately 330 million light-years, this vast region contains far fewer galaxies than scientists would expect, making it one of the most sparsely populated areas in the cosmos. The existence of such voids raises profound questions about the formation and evolution of the universe. How did these massive gaps come to exist in a universe filled with billions of galaxies? One theory suggests that cosmic voids are a natural consequence of the large-scale structure of the universe, which resembles a cosmic web of interconnected filaments. These filaments are made up of galaxies and clusters of galaxies, while the spaces in between the voids formed as matter clumped together under the influence of gravity, leaving behind these nearly empty regions. Another possibility is that voids offer a glimpse into the influence of dark energy, the mysterious force driving the accelerated expansion of the universe. By studying these empty spaces, researchers hope to uncover clues about the role dark energy plays in shaping the cosmos. Yet, despite their emptiness, voids are not entirely devoid of matter. They often contain sparse amounts of gas and even a few isolated galaxies, which offer rare opportunities to study how galaxies evolve in extreme isolation. These cosmic deserts are not just empty spaces, they hold the keys to understanding the forces that govern the universe on the grandest scales. The Borealis void and other voids like it remind us that while the universe is teeming with stars and galaxies, it is also defined by its absences. This interplay between presence and emptiness is a fundamental part of the cosmic story. As we leave behind these vast and silent voids, we now turn our attention toward the Milky Way's hidden halo, an ethereal feature that extends far beyond the galaxy's visible edges. Now turning to the Milky Way's hidden halo, we uncover an astonishing feature that stretches far beyond the galaxy's luminous core. This faint halo, composed of stars, gas, and dark matter, forms an immense and nearly invisible envelope around the galaxy, extending hundreds of thousands of light-years into space. What makes this discovery so remarkable is the role this halo plays in the Milky Way's gravitational makeup. While the stars and gas visible in the central disk of the galaxy are stunning, they represent only a fraction of the Milky Way's true mass. The hidden halo, dominated by dark matter, is believed to contain a significant portion of the galaxy's total mass. This mysterious component is responsible for the unseen gravitational pull that holds the galaxy together, preventing it from being torn apart by its own rotational speed. Researchers have pieced together evidence of the halo through careful observation of star movement and gravitational interactions. By studying the orbits of distant stars and globular clusters, ancient collections of stars that reside in the Milky Way's outskirts, scientists have been able to map the halo's structure and estimate its impact. Intriguingly, the halo's gas component is thought to be a reservoir for star formation, potentially containing clues about the Milky Way's past and future growth. This halo also influences the Milky Way's interactions with its neighboring galaxies, shaping how these celestial bodies exchange matter and energy over cosmic time scales. The Milky Way's hidden halo reminds us that what we see is only a fraction of the story. It's a testament to the ongoing mystery of dark matter and the complex forces binding the universe together. As we unravel the secrets of this elusive halo, we gain a deeper appreciation for the dynamic and interconnected nature of galaxies. Moving forward, let us venture into the realm of magnetars, some of the most powerful and enigmatic objects ever discovered in the cosmos. Now turning to the enigmatic magnetars, we delve into the extraordinary world of these rare and powerful celestial objects. Magnetars are a unique type of neutron star, the dense remnants left behind after a massive star explodes in a supernova. What sets magnetars apart is their staggering magnetic fields, which are billions of times stronger than the strongest magnets ever created on Earth. To put it into perspective, these magnetic fields are so intense that they can disrupt the atomic structure of matter and are capable of affecting objects from thousands of miles away. Magnetars are incredibly rare, with only a handful identified among the countless stars in the galaxy. Their rarity makes them a fascinating topic for astronomers as they provide insights into extreme astrophysical phenomena. One of their most captivating features is their ability to produce X-ray flares and bursts of gamma rays, some of the most energetic events observed in the universe. These flares occur when the magnetar's intense magnetic field twists and rearranges itself, releasing an enormous amount of energy in mere seconds. In fact, a single flare from a magnetar could release more energy than the Sun produces in 100,000 years. Scientists believe that these bursts may also help us understand the origins of mysterious cosmic phenomena like fast radio bursts, which are sudden, high-energy signals detected from distant regions of space. Magnetars are not only a marvel of astrophysics, but also a reminder of the universe's sheer power and unpredictability. With each new discovery about these enigmatic stars, we inch closer to unraveling the secrets of their existence and their role in the broader cosmic landscape. As we leave the realm of magnetars, we shift our focus to the largest known structure in the universe, a discovery that challenges the very limits of our understanding of vast cosmic scales. Now turning to the largest known structure in the universe, we encounter the Hercules Corona Borealis Great Wall, a mind-boggling assembly of galaxies that stretches over an astonishing 10 billion light-years. To grasp the sheer magnitude of this cosmic structure is nearly impossible. It defies our everyday understanding of size and distance. This colossal formation is composed of countless galaxies bound together by gravity, creating an interconnected web of matter that spans a significant portion of the observable universe. Its discovery shook the scientific community as it challenges the widely accepted cosmological principle, which suggests that the universe on a large scale should appear uniform and isotropic, meaning it should look the same in all directions. The existence of such an immense and uneven structure raises profound questions about how the universe evolved and whether our current models of cosmology are complete. Mapping the Hercules Corona Borealis Great Wall required advanced technology and meticulous data collection from telescopes capable of capturing light that has traveled billions of years to reach us. Each faint glow represents entire galaxies, each housing billions of stars, planets, and potentially life. It is not just its scale that fascinates scientists, but also what it tells us about the distribution of matter in the universe and how gravity shapes the cosmos over time. Studying such a vast structure gives us a rare glimpse into the universe's history, providing clues about the conditions shortly after the Big Bang. As we marvel at this immense cosmic tapestry, it is a humbling reminder of the scale of our universe and how much there is yet to explore. Speaking of grand discoveries, we now turn our gaze to the concept of dead galaxies and the mysteries they conceal. Now turning to the eerie concept of dead galaxies, also known as galactic graveyards, we find a fascinating yet solemn chapter of the universe's story. Dead galaxies are those in which star formation has ceased entirely, leaving behind a collection of aging stars, remnants of what were once vibrant stellar nurseries. Over time, these galaxies exhaust their reservoirs of gas and dust, the essential ingredients for creating new stars. Without this material to fuel their growth, the galaxy becomes stagnant, unable to birth new stars and slowly turning into a hushed cosmic relic. Scientists believe this process can be triggered by a variety of events. For some galaxies, violent collisions with other galaxies strip away their star-forming materials, effectively shutting down the creation of new stars. In other cases, supermassive black holes at their centers may unleash powerful jets of energy, expelling the gas needed for star formation and permanently silencing the galaxy. What remains in these galactic graveyards are older stars that gradually dim as they age. Over billions of years, these stars either burn out entirely or collapse into ultra-dense objects like white dwarfs, neutron stars, or black holes. The lack of new star formation often leaves these galaxies with a faded, reddish glow, a stark contrast to the bright blue light of younger, star-forming galaxies. Dead galaxies serve as cosmic time capsules, preserving the history of the universe's earlier eras. By studying them, astronomers gain valuable insights into how galaxies evolve, the role of star formation in shaping their structure, and the dramatic events that can alter their fate. These silent, ancient giants tell a story of life and death on a galactic scale, offering a glimpse into the natural cycles of the cosmos. With the mysteries of these cosmic ghost towns unraveled, we now conclude our journey through the most bizarre galactic facts by looking ahead to the future of our very own Milky Way and what lies beyond. With the next phase of the journey in sight, let us delve into the future of our very own Milky Way galaxy and the remarkable events that await it. One of the most extraordinary predictions in cosmic science is the impending collision between the Milky Way and its closest neighbor, the Andromeda galaxy. Hurtling toward each other at speeds of over 2 million miles per hour, these two massive spiral galaxies are on a collision course that will come to fruition in approximately 4.5 billion years. While this might sound catastrophic, the vast distances between stars within each galaxy mean that direct collisions between individual stars are highly unlikely. Instead, the gravity of the two galaxies will intricately weave them together, stretching and distorting their shapes before eventually merging into a single, larger entity. Scientists predict that this new structure will likely take the form of an elliptical galaxy, a spherical or football-shaped galaxy quite different from the flat spiral designs we are familiar with today. As this transformation unfolds, star formation may see a temporary resurgence as clouds of gas and dust collide and compress, igniting new stellar nurseries. However, over time, the supply of star-forming material will diminish, leaving the newly formed elliptical galaxy with fewer young, bright stars and a more subdued reddish hue. This cosmic dance between the Milky Way and Andromeda reminds us of the dynamic and ever-changing nature of the universe. galaxies are not static. They are living, evolving entities that grow, collide, and transform over billions of years. By studying this inevitable collision, astronomers gain a deeper understanding of how galaxies interact and evolve on a grand scale. While the timeline for these events far surpasses the span of human history, it is humbling to imagine the future shape of our galaxy and its role within the vast cosmic tapestry. The universe is a constant reminder of both its grandeur and its impermanence, showing us that even the most stable structures are subject to the unyielding force of change. As the sun rises on the next chapter of our cosmic contemplation, let us consider the deeper implications of the Milky Way's evolution and what it could mean for the future of life in the galaxy. The collision with Andromeda and the resulting transformation into a new elliptical galaxy will not just alter its appearance but could also reshape the conditions for life as we know it. The redistribution of gas, dust, and the birth of new stars during the merger may create unfamiliar environments, potentially fostering regions where life could emerge or thrive. On the other hand, the eventual decline in star formation and the shift toward a fainter, older galaxy might limit such possibilities over time. Yet, humanity's fascination with the stars is not bounded by the changes looming billions of years in the future. We continuously search for answers to the greatest question: are we alone? Exploration of exoplanets within the Milky Way has revealed an astounding number of worlds that could harbor life, and advancements in technology might one day enable us to reach them or communicate with other civilizations if they exist. The potential for humanity to evolve alongside the galaxy, to extend our reach beyond the confines of Earth, and to become an integral part of the Milky Way story is both a profound challenge and an inspiring dream. While the galaxy as we know it will transform beyond recognition, it is the resilience and curiosity of life, especially intelligent life, that could continue to adapt and endure. This enduring partnership between life and the cosmos serves as a testament to the unyielding connection between the universe's vastness and the intricate web of possibilities within it. And so, as we reflect on the strange and wondrous facts that define our galaxy, we are reminded of the boundless potential for discovery, growth, and survival that lies ahead. The Milky Way is not just a backdrop to our existence, it is a living, evolving cosmos that invites us to explore, adapt, and imagine our place within it. As we reach the conclusion of our journey through 30 bizarre and fascinating galactic facts, it becomes clear that the universe is far stranger and more wondrous than we could ever imagine. From rogue planets wandering alone in the dark to supermassive black holes anchoring entire galaxies, each fact reinforces just how little we truly know about the cosmos. The mysteries of dark matter, the sheer scale of structures like the Hercules corona Borealis Great Wall, and the enigmatic signals from deep space all serve as reminders of the questions still waiting to be answered. These galactic phenomena not only inspire awe but also fuel our unrelenting curiosity to explore, understand, and perhaps one day uncover the secrets of the universe. The galaxy, with all its strange wonders and hidden truths, is a vivid testament to the boundless complexity and beauty of existence. As we continue to look up at the stars, may we never lose the sense of wonder that drives us to seek out the unknown and imagine what lies beyond. What was your favorite galactic fact? Are there other cosmic questions you are eager for us to explore? Let us know in the comments below, and do not forget to like the video, subscribe to the channel, and hit the notification bell to stay updated on our cosmic adventures. The universe awaits, and together we shall continue to unravel its greatest enigma.